Alsop with ShopSabre CNC. Around here they call me Router Bob. We've got a video today that's really directed if you're maybe considering becoming a CNC cabinet shop. So we're starting out with our flagship product, and that's the Pro Series, and it's a 4x8, so that's a great way to start. And we're also going to look into the software. We're going to use Mozaik. We're actually going to go through Mozaik. We're going to create a base cabinet, which I call base test, and we're going to go through the whole process and finally cut it on the machine. So hopefully you'll get a really good understanding of how this whole system works, and you'll realize you can do this too. You know, people ask me often, how do you tell the quality of a CNC machine tool? And really, I start at the ground, to tell you the truth. I look at the frame first, because if the base frame's not right, nothing else is right. The frame gives you the accuracy of the machine. It also gives you the edge finishes. Now, the other thing I would suggest that you open the hood. You know, there are a lot of cover panels on these machines. Take those off and see what it looks like inside. If you see quality welds on the outside and junk on the inside, that tells you a lot about the company. Now, we're fortunate here in Elko, Minnesota, because in our factory, we build these machines. And I just happen to have a base frame that just came out of the machine shop, and I have another one that just came out of paint. So let's go take a look at it so you can really see how these frames are built. Okay, this is the base frame for a Pro Series. Now, one of the things I want you to look at is the quality of the materials we're using. Now, there's actually 3 other frame parts in the machine. Of course, this is the base. There's also a gantry, and there are 2 supports for the gantry. Let's look at this first. Now, first off, the material is structural steel. We use structural steel because the physical characteristics are very predictable. Therefore, we can plug that into software, and it can evaluate our design and tell us weak and strong spots, so that we can make sure that it's a really, really rigid structure. And that has a direct effect on your cut quality and the accuracy. Now, once that weldment's done, then we stress relieve it, because the heating process of welding creates stresses. And once we machine it, we don't want those to release. So we stress relieve first, then we do the actual machining on this in one setup on a huge aerospace quality mill. So the accuracy of all our machining on our frame is that mill's accuracy. That's how you build a really, really nice machine. Let's take a look at this weld and look at the quality of that. You know, I always figure welding is a very highly skilled trade, and a welder's weld is their signature. And what I always look for, you know, when you get down into the frames and stuff, look at the quality of the welds that you're not going to see when the machine's assembled. These are just as good as the visible ones. That tells you a whole lot about the company, and also tells you why you need to open the hood up and see what you're really buying. Okay, this machine gets a vacuum table. Now, in order to do that, we have to have a method to get vacuum to the table from the pump. And how that's done is called a vacuum manifold. So what we've done is we've actually integrated that functionality into this cross frame member. And we bring vacuum in from here, from a 4-inch hose or pipe, and then we distribute it through these smaller ones through very large valves. What that means is you get as much vacuum as possible through the table to your part. That's a really, really clever design. These are the other 3 parts of the frame structure, and that with the base really contribute to why the machine's cut so well. Okay, so this is the gantry. It's made out of 3/8 thick structural steel. They're capped on the ends. These are support posts. All right, both these surfaces are machined, so they get a perfect mated surface. And these are the datums that are machined to mount the guide rails to. Now, this assembly is ready to go to paint. All right, here's a base frame that just came out of the paint room. It looks magnificent. We paint these with a really high quality industrial enamel, and it's very, very durable. And boy, does this thing look good. Now we basically opened the hood and we've looked inside. Now you know how we do this. Now let's go back over and look at the other features on the machine. Okay, to make the machine easier to load and unload, we actually integrated into design welded in tubes for forklifts. And you can see the openings here. And oh, by the way, there are not openings on the other side, so you can't pick the machine up from the wrong side. Okay, now here's a gantry assembly that's mounted on a machine. Let's look at that a little closer. Now, these are called precision contour guide rails, and they actually control the movement in all the axes. One of the things we did on the machine, on the y-axis, we mounted those up underneath here so it keeps dust off of them. All right, now, these are all sized. In fact, the spacing on these and the size of the guide rails are all determined by the design software, because it evaluates all the loads. So it makes a tremendously fine machine tool. Now, the way we make all these parts move around on the machine is with precision ball screws. So in the y-axis, we actually use one on each end of the gantry, and because of the length of those ball screws, especially on our larger machines, we rotate the ball nut. That takes care of the whip. It's not necessarily normally on the X-axis or Z because they're shorter. All right, but I get asked this question all the time about, well, should my machine have ball screws or racks? Well, we use both here, but there's certain instances where a rack makes sense, primarily where accuracy is not that big a deal like a plasma. If you're doing real precision machining, you're going to need a ball screw. Okay, now let's unpack that a little bit. Why is it? Well, when you have a rack system, it's driven by a pinion, and there has to be backlash for it to work. You can't have it perfectly tight or it binds up. Backlash is play, and the typical setting for a moving gantry machine is probably 3 to 5 thousandths of play in each end. Well, sometimes that doesn't matter, sometimes it does. When you use a ball screw system, we actually use matched balls to the system, and what that does, it actually means the ball's a little bit bigger than the slots, and that's called a preload, and when you have preload, there's no play. That's why ball screws are more accurate. Now, think about an application. If you're doing MDF doors, which are really, really hard to make correctly, don't even consider a rack because you'll be very disappointed. You'll have to have ball screws. So we use ball screws because it's a higher precision and it makes a better machine tool. The other part of motion control is the actual control. That consists of the machine control, of course, and the motors and drives that make that work, and of course the wires are connected. We use Mitsubishi AC closed-loop digital servos for the motors, and they're really, really well known. We also use matching Mitsubishi drives to control the motors. Now, the wiring's interesting because if you think about what happens to the wires on these machines, it's constantly flexing. So we use a continuous flex robotic wire, so it's designed for that. Now, some companies don't do that. They use less expensive wire, and after time, one of those wires breaks and you got an intermittent problem or the machine's down altogether. I'm really pleased with the ShopSabre controller. We started out with a really solid architecture for control, and then we built on that. And our goal, our design goal was to actually create something that was real simple to use. It had all the functionality of a control. It was one screen, and you could teach somebody to operate it very quickly, and we really accomplished that well. And it runs parallel to Windows, therefore I can run programming software on here or cabinet software or whatever I want. So it's really the best of both worlds. The machines have HSD spindles. We can actually offer you a tool changer spindle in a 5 or 10 horsepower. But I want you to look at the design concerns that went into this. If you look at these side plates here, basically those are added onto the motor plate itself to stiffen it. That equates to a more rigid spindle where you're cutting, and that gives you better edge finishes and more accuracy. The other thing we did is we actually put a cylinder up here. Now that's a counterbalance cylinder is what that's called. If you don't have that, all the mass of this spindle is on the ball nut and the ball screw. All right, when we use this, we actually use air pressure to balance that, so we take all the force off the ball screw. So that's a really nice feature. That makes your ball screw last a whole lot longer. One of my absolute favorite parts of this Pro Series is the vacuum table. Okay, this machine's a 4x8, but it's not really 4 feet wide, it's a lot wider. All right, if you think about it, first off, we designed the machine so we can fly cut the table on the machine. So that means we have enough travel. That means I can make this table on the machine. What's neat about it though is, think about why people buy 5-foot machines. Probably half of them buy 5x10s so they can cut that Baltic birch that's 5x5. You can cut it on our 4x8 because we're wide enough to do that. That's an unbelievable feature of this machine. Now also we have pop-up pins, and we'll see those in a minute when we cut. So they pop up, so that lets us put our spoil board on there and then our parts. And the funny part about pop-up pins is if you ever talk to somebody that's used them, most people have actually cut them one time or another. They forgot to put them down. That can't happen here because as soon as the spindle turns on the machine, it pulls those pins down. So you really don't have to worry about it. So it's an incredible design. And the other thing I look at is look at how big these holes are and look at how much circulation we have. It's an unbelievable vacuum table. Okay, the other part of the vacuum system is the pump itself. Now we've already looked at the table, we've looked at the manifolds, but now we get to the pump system. ShopSabre offers all the standard pumps, regenerative blowers, Becker pumps, all that kind of stuff. But there's quite a few small shops that only have single phase. So in the past, what you've had to do is to either use a phase converter with a 3-phase pump or a VFD to drive. But either way, it's a lot of trouble. All right, so we came up with, I call this the magic box, is what I call it. It's technically the ShopSabre F4, but it's an incredible piece of technology. Here's how the thing works. If you look at regenerative blowers, here's what happens. If you crank them up real good, they get hot and they melt down. That's why you have these little bypass valves on them, so they relieve the pressure. Well, what causes that? Well, we have to do that because they get hot. Well, what if I could control the temperature? So what if I used an approach where I could cool it enough that I didn't have to have that relief valve, so I get a whole lot more performance out of the motors? Then I take high performance motors and I put 4 of them together, and when I'm done I have as much vacuum as I have with a big regenerative blower, and it only takes 30 amps a single phase. It's miraculous. Wait till you see this run. And I can turn on any of the 4 motors. They operate together or independently. There's no backflow. Wait till you see this. All right, we almost have the machine prepared to run a cabinet nest, but what we just finished was we fly cut the spoil board. The spoil board itself is made of MDF, and we fly cut both sides so we get into the porous section of it, and then the plywood actually lays on top and vacuum pulls through it. That's how it works. Now, I want to show you something. Here's our part locator pins, and you notice we don't require any gasket under the spoil board because our machining is so accurate. Because we do it on the machine, we don't need gasket underneath there. A lot of machines require gasket. Now, what we do next is our pins are up, and all we do is push this into the corner that's located, and then the next step would be put our sheet of plywood and we can cut cabinet parts. But before we do that, let's do one more thing. Let's talk about tool changers, and let's talk about tool touch off, and then we'll go up into the office and we'll create the program for our cabinet. We just finished our tool touch-off. Now we have everything set. Now we really haven't talked about the ATC. That's called a rack, and the beauty of a rack is there's no moving parts, so your odds of having a tool change issue are really rare in that. Now this is a 5-position tool change rack, and that's adequate for making cabinets because it's the drill and your router bits and your fly cutter. So that's really 5 tools. Now, keep in mind, if in the future you need to expand that capability, that can be done in the field because the machine has the ability to do required machining for that. So just keep that in mind. Now, we've got this set up. Now let's go back and focus on what we're actually going to produce on the machine, and we're going to create a base cabinet that you would start with Mozaik. So the next step is to go into the front office, look at the software, and create the program we need out here. When we're done, we'll be back out at the machine and we'll make that cabinet and validate what we did on the software. You know, the whole concept of nested base manufacturing absolutely revolutionized the kitchen cabinet business in the United States. It was really developed around, the late 90s, early 2000s. And in a very short period of time, it became, the way of manufacturing cabinets. I always said nested base allowed the small company to compete with the biggest factories at the time. Now, as we've seen this evolve, at first, the machines cost a lot of money, $150,000 to $200,000 for a machine to do what we're going to do today. As we've seen this whole industry evolve, all of a sudden the price of the technologies come down. When I first started, the machine cost as much as a purchaser's house normally, or even more, so it was a huge purchase decision. Nowadays, the cost of the machine technology is about what a nice pickup truck costs, so it's a much simpler decision for the customer. Okay, what you see on the screen here is the Mozaik software. Now, let's go through the process that it takes to actually set this up to make your cabinet on your ShopSabre CNC. Okay, before we open a job, we really have to teach the software how we want to build a cabinet. We call that the construction method. So go to libraries, and when you bring up libraries, there are the products, and products are organized in catalogs. In this case, we're going to do a frameless cabinet. We're going to start with a base cabinet. And let's look at it in 3D and see where we're at. We may not have to change anything. All right, here's the cabinet, and let's x-ray it where we can see that, yeah, there it is. That's nice. Now, this is a CNC construction method for a cabinet that I happen to like. Now, I would recommend it, at least on starting, that this is what you start with. Now, you may have a certain cabinet construction that maybe you've used for 20 years or that you want to integrate into this, and that's fine. but you're better off if you start with the CNC cabinet method we know works and it's easy for you to be successful. All right, let's look at this a little further. If you notice, you see that these are stretchers, top stretchers, and you notice they're blind on the ends, and this drawer stretcher is blind also. That's so that that fits into a joint a certain way, and then because those are set back adequately, you can actually edge band the front of that stretcher, and the trimmers will catch those ends just right. Okay, you'll see a bunch of holes in there. There's holes for drawer guides. There's holes for adjustable shelf holes. There's holes right there for the hinge plates because it's a frameless cabinet. So the machine's going to do all that for you. There's one other little setting I've got here, and if you notice right here, I'm actually adding some holes in the bottoms of these dados. And the idea is that those serve as screw guides, really, so that you can use screws to assemble the cabinet on unfinished ends, and it just makes it simpler. On a finished end, we wouldn't use the screws. The software's smart enough, it knows what to do on those. So that's basically our construction method. Now there's one other part of that, and that is how I handle the back. Now there's a number of ways you can do backs. You can use a thin back and nailers. I prefer to use a back made out of the same material because of yield. And the back can actually slide in after the fact, and it has a tendency to square the cabinet. So this is a really, really good construction method to start with. Once we've taught the software how we make a base cabinet, we would also do the same thing for a wall cabinet and tall cabinet. And those are the first 3 cabinet tests that we do when we integrate to the machine. If those all fit and everything works, then everything else in the system is probably going to work for you. Now let's carry this to the next step. Let's go back to our libraries and let's see what else we have. Okay, next on the library list is materials. Right, now this is simply what kind of material are you making the products out of. And once again, the material catalog you see here is the generic one. Now, let's look at a couple of items on there. One is what size is the material. That needs to be accurate. The thickness is really critical too, and not so much using table saws, but it's really critical in CNC because we machine joints based on how thick that material is. So if in fact you measure the material and it's 0.72, that's what needs to be in there because our joints are going to fit better. Okay, as you move on down, does it have grain or not? If it's plywood, it probably has grain. When you see these areas that say width trim, length trim, basically when we nest these parts on the sheet, we're always going to leave a margin along the edge so that we get rid of all the factory edges. A couple reasons for that. One is obviously the factory edges get damaged, and second, the part then picks up the accuracy of the machine itself. So all of a sudden now those parts get very, very accurate because the ShopSabre CNCs are extremely accurate because of the ball screw systems. Okay, once we've gone through our material catalog and made any adjustments that we need to make, let's close that. And now let's look at the next thing on the libraries, and that's material templates. Material templates basically tell the software what you want each part of the cabinet made. In our particular cabinet we're making today, we're going to use 3/4 inch plywood, and you see down the list here, if you see on here, there's a material thickness. It picked that up off of our material catalog. So that's how a job is determined, the material that's used in it. So you might have a walnut material template, a birch material template, a melamine material template, but basically that's what tells the software what you want each part made out of. Right, then we'll close that. And if you notice in the libraries, there are other libraries also that are parts, doors, drawer boxes. Everything basically works the same way. Okay, now that we've kind of looked at the underlying part of this and we've taught the software how we want to build our cabinet and we've made sure the material is correct. Now let's create a job file actually to make a base cabinet. So we start out with File, New. We're going to name this file Base Test, and that creates the job. Now you notice when the job's created, some other things pop up. For instance, settings. Settings determine everything about the job, what kind of material you're using. I think I have the defaults already set up. We're going to use 3/4 inch plywood. It's a frameless cabinet, so we're using a frameless hinge. We're also using drawer guides. Now, if we were really creating a room or a kitchen, we could start at room layout, but look, we just need a cabinet, so we can go to order entry. So I go to the order entry tab. I always tell people order entry is for people who don't need a pretty picture, they just need a cabinet. All right, so we're going to go to our frameless catalog. We're going to select our base, drag it over. Now let's validate that it is what we think it's going to be. So I hit edit and we'll look at the viewer. Let's make sure that it's what we think it's going to be. Okay, that looks like it. Joints look good. Excellent, excellent, excellent. Okay. We'll close that out. Right. And then the next thing we'll do is I happen to know that if we make this cabinet 23 inches deep, it fits on one sheet of material. So we'll do that to save material. Then we go to cut list, and cut list then gives us the optimize button, and then the optimizer actually allows us to do the nesting. So let's go to that, the optimization. The optimization part of the program is actually where the part nesting comes in. So let's talk about that a little bit. What's happened in the software, in the design part, basically we design the cabinet. We taught it how we build a cabinet, we set the materials. At this stage then the software has created basically an electronic drawing of every part. Then those parts are separated by material and nested for yield. So that's really what optimization is. Before we get into that actual activity of nesting, let's stop and let's talk about the tooling a little bit that's going to be required. So what I'm going to do is go up to the library that says CNC tooling, and there's a tab over here that says tool set. Think of a tool set as how we have the machine set up, and I'm going to call the tool set that we're going to use on the router the cabinet set. Now this is what determines what actually is in the machine. So tool number 1 is a 5mm drill. Tool number 2 is a 1/4 inch down shear. Tool number 3 is a 3/8 down shear. Tool number 4 is a 3/8 compression. 5, 6, and 7 are left empty. And tool number 8 is an 1.5 inch fly cutter. Those are the basic tools that we almost use on every cabinet job. So now let's stop and let's look at each of those tools in a little bit more detail so you understand how each one of them cuts. Okay, now let's take a look at the actual tools that we're going to be required to make kitchen cabinet parts on a ShopSabre CNC. Now this is the cabinet set that we had set up in Mozaik. So the first tool is a 5mm drill. The second tool is a 1/4 down shear. The third tool is a 3/8 down shear. And the fourth tool is a compression spiral. And of course the tool number 8 out here is the fly cutter. Now let's look at each one of these in a little bit more detail. All right, first, this bit is a 5mm brad point bit. It's used to drill holes. Typically, we put this in tool position 1 because that's the first operation we do. We drill holes in the entire sheet. The second and third tools are very similar tools in that they're down shear. Tool number 2 is a 1/4 inch down shear. Tool number 3 is a 3/8. The configuration of cutting is the same. In case you're not familiar with the term down shear, think about down shear and up shear. A drill bit is up shear. As it turns, it lifts the chips upward. Well, when you're routing, that can disturb the surface veneer sometimes on panels. So we use the opposite of that, which is a down shear. So the cutting action actually pushes the top surface down and you get real clean edges. Now, we typically use the down shear bits for the non-through features, dados, grooves, those kinds of things, anywhere where we're not cutting all the way through the panel material. Then tool 4 is called a compression bit. And a compression bit is a combination. Part of it's up shear and part of it's down shear. Now this happens to be a special compression bit called a mortising, and that simply means that this tip that's the up shear is limited in size. Whereas most of the cutting bit itself is going to be down shear. The advantage of a compression bit is it cuts without chipping top or bottom. So that's why we use that. And of course our last tool is a fly cutter. This happens to be an 1.5 inch fly cutter. It's fairly inexpensive, so if you drop it on the floor, it's not that bad. Now, the limitation of this is it's 1.5 inches, so it takes longer to fly cut the spoil board. Now, we also have these bits available in 2.5 inch diameter and 4 inch diameter, depending on what your production needs are. Okay, now let's carry this optimizer further. Okay, so we basically know what the tools are. Now, there's actually a list of all the parts. And you can actually edit each part at this level. In fact, if I wanted to, I could add a holder part. But at this point, let's just go to Optimize. Everything's set up. We just say Optimize. And there's our nest. So now there is our cabinet, and it fits on one sheet of material. And now we're ready to actually go out and G-code this and send it to the machine and cut this out and put it together and see if it fits. So here's how I do that. I select Generate G-code. Calculates. Now what's going to happen if you look at this, if we move this over and you can see it, right, all the highlighted ones here, that's the drill. Then we're going to use the 3/8 down shear. That's what it's going to cut here, and it's going to cut the outside. So all we say is generate G-code for all the parts, and that just created our program. Now we take that program to the machine and we run it, and then we put the cabinet together, and if everything's right, the parts fit. All right, we've completed the program we need for testing the base cabinet. I've put it on the machine control. We're going to add a sheet of material to the machine, and let's cut the cabinet and see if it fits. It really looked good when we cut it. Now let me see what we got here. All right, here's a piece. Wow, 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 wow. Look at the edge finish. Now, that's what you get when you have a frame structure like we got on this machine. This is the result. It's really, really smooth. It's cut, there's no defects, so that's what we're looking for. Now, if you notice, everything worked out so far. In fact, if I already check here, my dados are just right. Now, sometimes they're loose, sometimes they're tight. If they're too loose, you can live with it. If they're too tight, that's another problem. Okay, so my next step is let's go ahead and put this together and see if everything fits. And then if we were actually setting up an integration for Mozaik with the machine, the next thing we would do is the same process except with a wall cabinet and finally a tall cabinet. And if you get all three of those assembled correctly, everything else seems to work. Well, our cabinet came out very, very good. Now, if you notice, all the parts fit. Now, this is actually the adjustable shelf. There's the holes for the adjustable shelf. There's holes here for the hinges for the hinge plates. There's also holes in there for the drawer guides. So it came out really nice. You know, the fit was pretty good. One of the things that's difficult the first time you cut one is to get the fit right. You know, basically the dado width is determined by the material thickness in the material catalog, and so sometimes you tweak that if you want it, but we came out pretty good on this. It went together well. If I were going to do anything, I might loosen it just a little bit because sometimes it's harder to get them together. But boy, our base cabinet test really came out good. Now, so we're happy there. If it hadn't come out, then we would have made adjustments, cut another one until we got a correct one. Okay, now once this test is done, then we do the same thing for a wall cabinet and a tall cabinet. When all three of those are configured, Mozaik's set up, the CNC set up, and then you can really start making cabinets. Well, I hope you enjoyed the video. We had a great time producing it. You know, our goal in this video was to actually show you or demonstrate to you what it takes to be a CNC cabinet shop. And that's why we started with the cabinet and the software and actually went all the way through the machine process and assembled the cabinet. It came out great. The edge finish is magnificent. The machine performance was incredible. This just goes to show American ingenuity. Don't sell American ingenuity short, because ShopSabre CNC has proven that you can make a machine that's price competitive with anything in the world. If you need more information, go to ShopSabre.com. Thank you for watching.